Sorry?
Growth diagram.
Growth diagram. 120 of this was
120. C.
okay.
Then find charge.
Find charge. So how to do it?
C equivalent into V.
C equivalent into V. So C equivalent is 1 and V is 120, but don't forget the unit micro. So this will be 120 micro coulomb. Okay. Now
Find C1.
how?
Q by C1.
So you mean to say that we have this diagram, this is C1, C2 and C3. So now we are saying that we can find V1 as what?
Q by C1.
Q by C1. આ ચાર્જ તો આનો જ લખવાનો હોય ને Q1 by C1. Yes or no?
It is series. Charge are equal.
All the three are in series. So the charge here, here, here and here is equal. And here नहीं भूली जाता. Okay, भूली जाता तो आवाज़ तो solve नहीं. Is that clear? The charge here, here, here and over here will be same. So that is, this will be 120 micro coulomb divided by capacitance 1. How much? 2 micro farad. So mu will get cancelled and this will be 60 volt. Understood? Is it?
Yes.
But yes, you have to follow it the right way. The same way and find the other one. Sit down. Well done. Okay. Similarly, the other two. Okay, Q2, actually it will be Q2 by C2, but here Q2 is same as Q because they are in series. So that's going to be 120 by 3, that is 40, and the last one will be similarly 20. Clear or not?
Yes.
Method clear?
Yes.
Everyone? Good. Okay, our government life part. Okay, fine. Right. Now let's go over to the next thing, that is for parallel. Do not take these sums lightly. Probably these are going to be your only joy in 12th standard. Okay, now next capacitors in parallel. So the pehla to yaad kar that if it's not series, then it's not necessary that it is parallel. Is that okay? Khali page no hai series parallel, right? There is also a third possibility. Got that? Keep that in mind. The series nathi, એટલે parallel nahi karano. Is that clear? Be careful. In fact, it is actually tougher to identify parallel than it is to identify series. Series is बहुत simple. You start walking from one to the other. If you get it without any branches, that means they are definitely in series. Okay? Good. Now what about parallel? How do you identify? Let me draw it, that will help you identify a little bit easier. So these are, suppose two capacitors, they are in parallel. Parallel to meaning ये नहीं कि ऊपर नीचे draw करेगा. बाजू में draw करेगा तो parallel draw है. Okay? So how do you identify parallel? We will try to describe what we are seeing. See, a wire comes up here from this at this point, and then that wire splits. So this wire goes here, okay, and this is all connected to each other. Yes or no? So this same thing, the same wire, which is connected to this. So this one and here, these are connected with each other. Yes or no?
Yes.
Sure. Is there anything else in between, any other instrument or device like capacitor, resistor, battery, etc.? आपके निवास के बीजू है, नहीं बोले? Sure. This is a junction. मनी junction पे क्या है नहीं? Okay, junction means where the wire splits. Is that okay? Or where the road splits? Got it? Sure. But this is not some device. It's just a point. Between this and this, is there anything? No. Is that fine?
Yes.
But that's not enough. The same thing should happen on the other side. That is, on this side also, between this and this, is there any other device? you go from A to B directly without having to cross any other device? Yes or no? Yes or no?
Yes.
Yes. અહીંથી આમ જાવ તો અહીંયા પહોંચી જવાય ને. You don't have to cross any other device. Clear? Device કોને કહેવાય? Battery, capacitor, resistor, etc. etc. બીજા આવો. Understood? So you can go from here to here, A to B without crossing any other. Similarly, can you go from B to E without crossing any other device? How big budget how you? Only then they are in parallel. Is that clear? So basically, you can also say that there should be two common wires on both sides. Two common wires can go. આ wire અહીંયા છે અને આ wire અહીંયા. Did you understand? Yes or no?
Yes.
Sure. First thing, parallel can never be without a branch. Parallel is impossible without a branch. But every time there is a branch does not mean everything is in parallel. You understand what I am saying? Every time there is a branch does not mean everything is in parallel. Okay? It's like branching is necessary for parallel but not sufficient. If you understand that language. Branching is necessary for parallel but not sufficient. What is sufficient? This is sufficient. Two wires from two sides should go together. Did you get that? एक बाजू नहीं हो खाली. It should be on both sides. Right now you might be thinking that एक बाजू पर तो बीच में થાય જ છે. હમણાં સર્કિટ આવે છે. Okay, in this one it looks like that, but it's not always. Is it fine? So let's write a sentence first of all to identify. Is that two capacitors have common wire on both sides, then they are in parallel. This is the way to identify parallel. If two capacitors have common wire on both sides, not just one. Common wire, this A to B is just one wire. It's a common wire for capacitor 1 and 2. Similarly, on the other side also, this D to E is a common wire. The एक જ wire બે ને અડે. That means they are in parallel. Why am I describing all this? I know you might be thinking, sir, हमने तो જોઈને જ ખબર પડી જાય કે series parallel. એ બે દિવસ રાહ જો બધું નીકળી જશે. જોઈને ખબર કંઈ જ નહીં પડે. Okay? So you have to be very careful. ટેન્થમાં તમારે ખાલી આમ સીધા સીધા સાઉન્ડ આવતો એટલે તમને એવું લાગે કે આ સીધોને ખબર પડી જાય અને પેરેલલ કહેવાય નથી રીતે એવું ન હોય. Okay. Well, so this is what we have got, right? Now let's derive things for this. Let's begin. Okay, you got sentence. Okay. Now here what would happen is, think about it, that if some electrons, this is the negative plate of the battery, this is the positive plate. So just like it was earlier, the positive side will be positive also. Yes or no? Yes. Do you remember? So this will be plus, and this will be minus, this will be plus, and this will be minus. Clear? Now let's say this is storing a charge Q2, that is plus Q2 minus Q2, and this is storing a charge Q1, that is plus Q1 and minus. Is that fine? Clear so far? Now, first of all, we will start with voltage. You see, do you realize that battery, this wire from here, this metal, all the way metal till here, yes or no? Clear? Similarly, metal till here. So, do you agree? Again, this is not supposed to be shocked to anybody. I said, hey, go to the but I don't know why. This is using math is very easy. તમારી બુકમાં તો સેટ જાય એ લોકોને આવું બધું ગમતું જ નથી. ઇક્વેશન નહીં લખવાની એટલે પેરેગ્રાફ લખો. VA is equal to VB. Clear or not? Why? Because they are all connected to the same metal wire. At every point on the metal will have same potential. If we are talking about electrostatics, that's what we are doing in this time. Right? Okay. Similarly, do you understand that VD is equal to V? Yes or no? Yes or no? Sure. Subtract equations. Yes or no? So what are we getting here? V1. V1 is given again, okay? V1 for what? V1 for voltage of which capacitor? First one. VA minus VD, that's called voltage of first capacitor. Fully get definitely. What is meaning of voltage of capacitor? Potential difference between positive terminal and negative terminal. Clear? Like positive and negative, positive plate, negative plate, plus VA and VD. Subtraction of those is V1. Similarly, on the right side, what do we have? V2. But that's not it. We see that ultimately A point is connected here and B point is connected here. So when the battery, suppose this battery supplies 12 volt, for example, then that same potential will go here and here. That's why the difference here will also be 12 volt. You understand what I'm saying? Again, A here, suppose you take one point X and one point Y, then Vx is also going to be same as Va and Vy will also be same as Vd. I hope that makes sense. That's why if the difference of Vx and Vy is 12 volt in it, battery gives 12 volt potential difference between negative and positive. Okay. So 12 volt. If this is 12 volt, the difference of these two is 12 volt, then the difference of these two will also be 12 volt. In short, it will always be same. Okay, in parallel. That is, in parallel voltages are equal. That's what we mean. Okay, now. In parallel voltage for each capacitor is same or equal. Okay, this is a useful relation for parallel. Please start current. And reason what? As they are connected to the same wire. As they are connected by same wire. Very okay. But what about charge? Let's have you see. Suppose someone would tell you that you have a pipe, okay, with what is flowing, and now over here you have a branching in the pipe. And they would say, you see, charge flows till here. Now, charge has two ways to go. Yes or no? Yes. Which two ways? Either up or down. Clear? So, some of the charge may go up, some of the charge may go down. Is it necessary that they are equal? Not necessary. I hope you realize it. On the other hand, something interesting happens there. Suppose you would say that, let's say, 10 liter water flows here and 3 liter water goes here. Then how much should go here? Understood? Yes or no? Yes. You could say it's the law of conservation. Of what? Okay, and here it would be law of conservation of charge. Okay, so you could write that if battery or if battery supplies a charge capital Q, then the charge is distributed. The charge is distributed amongst the capacitors. Okay, charge is distributed among the capacitors. That is Q is equal to Q1 plus. Okay. આજે ક્રોસ કર્યું છે ને એ બધું યુઝલેસ નથી હો. That is, to be very frank, even more important than this derivation. Okay, because they are general principles that we are going to use throughout. ઓકે આ ચેપ્ટરમાં એના પછીના ચેપ્ટરમાં પાછા એક બે ચેપ્ટર છોડીને લાઈક ધેટ ડીડ યુ અન્ડરસ્ટેન્ડ ઓકે દે આર વેરી ઇમ્પોર્ટન્ટ થિંગ આ જે વોલ્ટેજ ઇક્વલ કે જ આવે એનું પ્રૂફ છે ઓકે now this is also a very useful relation. Let's write it clearly. Okay, again it's an important thing is that in parallel total charge is found as Q is equal to Q1 plus Q2. Understood? In series, what do we have? Voltages are added. V equal to V1 plus V2 plus V3 and Q is all same. Q equal to Q1 equal to Q2 equal to Q3. Voltages are equal. V equal to V1 equal to V2 everything. And charges added. Clear? Q equal to Q1 plus Q2 plus Q3. 120. Okay. Right? And reason લખો એ તો લખી શકો. This is law of conservation of charge. Right? The reason for this is law of conservation of charge. બોલો તને સમજાવતી વખતે. Okay? Well, so this is very important. And can charges be equal in parallel? No, that's not the rule. But by coincidence, they can be equal. Just like in that question we saw yesterday, in series also voltages were equal by coincidence. In parallel by coincidence charges may be equal, but that's not the rule. Clear? Okay. Them column charge add no correct. If you remember, I told you that you cannot say Q equal to Q1 plus Q2 plus Q3. Voltage add no correct. If you say we have got a 12 volt battery, okay, 12 volt, 24 volt. No, it's not like that. Is that understood? Yes. You know, that is, to be very frank, the best analogy of that is this. What's the height of this step? Then you measure this leg's length. Yes or no? પછી ઓલાની measure કરો. પછી આની measure કરો. પછી આની measure કરો. And then you add there. No, it's very another one very. This is a practical analogy of what happens up there. Is that clear? It's not to be added because they are in parallel. Jo parallel se ke series se parallel se series nahi. Did you understand? Well, understood? Another interesting thing. एक उड़ाड़ी दो तो सुन तो height change થાય કે ન થાય? ન થાય ને? Yeah. Lesson learned. अपने कैपेसिटर नंबर एक होई तो voltage same हो जाए. Did you understand? The height is like voltage actually. It's a very powerful and probably perfect analogy. That height is like voltage. याद रहता है? पाक्कू ने? Well, so this is what we have got. Now we are going to derive. So for deriving the equivalent, we should take this. We should take this, and we should make equivalent circuit. Okay, how are we going to equivalent circuit draw? What will be there? Yes.
Q is proportional to V, and in parallel voltage are same, so that is the charge distribution same.
Sorry, what are you saying? In parallel, voltages are same. Agree? And
Q is proportional to V.
Q is proportional to V. Okay.
Charge distribution should be
Very good. Okay, fine. Sit down. So I hope everyone has understood his question. He's saying that if V is same, Q should also be same because Q is proportional to V. Okay, color 1. Y is equal to 5. Okay. So Y is proportional to X. Yes or no? Sure. Okay. In some other case, Y is equal to 3X. Yes or no? So if I put value of X as 1 in both, will I get Y's value same? Why? Why not? Same my एक नहीं Y proportional to X है. What's the difference? Constant is different. Same thing here. In first capacitor, that constant is C1. In second capacitor, that constant is C. Understood? That's why. જ્યારે આપણે સેમ હશે ને ત્યારે ચાર્જ બ્રેક કરશે એ જ હું કહેતો હતો. By coincidence, it sometimes happens that the charges are equal. When will that coincidence happen? When both the capacitors are also equal. Fine? Understood? Right? The proportionality છે, but we are still comparing two different cases where the constants are different. એટલે છે. Fine? Okay. Well, so here we have Q equal to Q1 plus Q2. Equivalent circuit draw થઈ ગઈ તમારે? હાલો થઈ ગઈ છે? Yes, no? Yes. પૂછી તો લો પણ એમ ભૂલવા પડે. Well. So here's the equivalent circuit. And this is the equivalent capacitance. Now, how much charge should this store? That's the question. It should store a charge Q itself. Not Q1, not Q2. Just Q. Reason. Like I said, when the battery supplied some charge, some of it went here, some of it went here. Okay, so it's like 10 liter water is flowing. So if it is supposed to do the same job together, then 10 liter water should flow. That is basically the charge that should come here should be Q. Plus Q and minus Q. Is that clear? Everyone got that? Sure. Only then together it will do the same job. For example, this stores 10 microcoulomb and this stores 20 microcoulomb. Then that means actually the battery gave 30. The battery gave 30. Why 30? Because 10 of it went here and then 20 of it went here. So if we want this to do the same thing as these two together, then it should not store 10 or 20, it should store 30. Is that clear? That is, it should basically take 30 from the battery. Right? So that's why only Q, neither Q1 nor Q2. But what is safe? Voltage. I hope you are seeing. Yes or no? Yes. Whatever is the voltage for first one, that is V1. Whatever is the voltage for V2, and second one, that is V2. So V1 will be V2 and that will also be same as this. Did you understand? Again, the sentence. In parallel, what is same? Voltage. Got that? So here, we can write 4 equivalent circuit. Like my sir used to say, circuit. So what is equivalent circuit? Here for this we have Q is equal to C equivalent into V. Yes or no? Left side clear? No, not clear. Clear or not clear? Yes. Okay, right side Q1 C1 V1. Yes or no? What will I put it? What will I do there? Q equal to C. Yes or no? C equal to Q by V. Q equal to C. Plus C2 V2. But what is V1 and what is V2? Same as V. Okay, just write it. But V1 is equal to V2 is equal to V. Therefore, C equivalent is equal to C1 plus C2. So easy. If there are more, keep adding. Understood? Okay. The relations are there. Resistance માં દેવું parallel માં આવતું દેવું series માં આવે આમાં. Is it fine? Do not get confused. કારણ કે resistance હતી પાછું third chapter માં resistance આવશે. આમાં capacitance માં resistance. Okay, be careful with it. Right? Okay. Right. Let's summarize what we have learned about parallel very quickly. First one is that how do you identify parallel? From both sides common wire should be there, that is you should be able to go from this to this without any other device in between. Branches don't matter in parallel, let me tell you that. You don't have to worry whether there is a branch here, no problem. But can we go from here to here without anything else in between? Yes, that means, and on one side, not just one side. From here to here and from here to here, both. Yes, then parallel, otherwise not parallel. Okay, again, if it's not parallel, that does not mean they are in series, because there is a third possibility. Is this fine? Sure? Everyone got that? Yes. So that's what I identify. There, second. What is equal in parallel? Voltage. That is V equal to V1 equal to V2. And finally, in equivalent also the voltage will be same. What is added in parallel? That is Q equal to Q1 plus Q2. Okay, like that. Total charge. Fine. And then the formula. C equivalent is C1 plus C2 plus C3 added up to as many as there are. Understood everything? That's all okay. Take your technical. Most people find parallel easier than series. In capacitor, that is. But I think, what I said, why people find parallel easier than series, they have to reason it. Because mostly in circuits, batteries are given. And battery is given means there is a fixed voltage. Okay, and that is what makes everyone feel that parallel is easier. Okay, parallel માં voltage આપી દો, voltage બધા મળી ગયું. You understand what I am saying? Okay, but series માં એને voltage આપી દો તો કઈ નથી. You have to find everything from start. Okay, well then, let's solve this question from the exercise. Number 7. 7 is a parallel order. Question 7. 3 capacitors of capacitance 2pf, 3pf, 4pf are in parallel. Must draw diagram, everyone. Question 2.7 from exercise. 2pf, 3pf and 4pf. તમે ગમે તેમ ડ્રો કરો એનાથી કોઈ ને કોઈ લેવા દેવા નથી. They are in parallel. They are in parallel. મજાક ન કરતો. They are in parallel. Is that clear? Wire ના shape ની સાથે કોઈ રિલેશન નથી. તમે પ્રેક્ટિકલ કરશો તો વાયર ને આમ સીધા કરીને ના. You should see a wire that we use in practical. એ તો આમ ક્યાંથી ક્યાં જતો ને ગોતવો પડે. You get what I'm saying? Yeah. Right? So you should have the skill to identify in every kind of weird case. They are also in parallel. Right? So, આપણે આવું ડ્રો કરશું. Yeah, here. So these are in parallel. Now they might be connected with some battery. Okay, like this. C1, C2 and C3. What do we have to find first one? Equivalent capacitance. Yes or no? Yes. Oh, okay, coming out. Second. Find the charge on each capacitor if the combination is connected to a 100 volt supply. So in parallel, what's same? Voltage. So for this capacitor, the voltage will be 100 because you see these points are just connected to the battery. Clear? For all the capacitors, V will be equal to 100 volt. Is that understood? Yes. Okay, now we want to find charge stored. લખવાનું exam માં લખવું પડે charge stored on first capacitor or C1 એવું લખો પહેલા is Q1 equal to C1 V1. How much is this? How much is this? 2 into 10 raised to minus 12 into voltage 100. That's 10 raised to 2. So my answer will be 2 into 10 raised to minus 10 coulomb. Understood? Yes or no? Yes. I can બીજા ફાઇન્ડ કરી શકાય ફટાફટ ચલો લખી લેજો તમે Q2 equal to 3 છે ને so it will be 3 into 10 raised to minus 10. Yes or no? અને પછી લાસ્ટ વન જો આપણે Q3 equal to 4 10 raised to minus 10. Okay, total charge કેટલો હશે? Total charge 9 into 10 raised to minus 10. Understood? Q equal to Q1 plus Q2 plus Q. Got it? Sure? Very good. None of the game fully. Okay? Shall I erase it? Yes. I don't know. Easy paper માં some house. Is that okay? Not kidding. Easy હોય તો આવું છે. ટફ હોય તો એનો question. અને it is એવો કઈ ટફ નથી, just a little bit trickier than this. But concepts અને sentences લગાવો જો યાદ હશે તો આવડી જ જશે. Example from the book. Number 9. Example 9. વચ્ચેનો portion dielectric ને બધું હજી છેલ્લે કરશો. Right? As usual, I don't agree with the order in which topics are given. Okay. A network of 4 10 microfarad capacitors is connected to a 500 volt supply. See, wherever they write supply, we can draw a battery safely, at least for the time being. Okay, so first of all, everyone will draw their own circuit diagram. Where number though? 9. 9. Okay. So where there is a supply, I will draw battery. You might ask, how do I know positive this way, negative that way? If nothing is given, you can draw it anyway. Panjo. Okay. Figure માં લઈ લે. Capacitor માં plus left side આવે. Yes or no? Yes. Do you see that? Yes. So that's why I think left is student. Okay, the color. Here is one capacitor. Circuit બરાબર draw કર દો. જોઈ લો. And here is another capacitor, I guess. Yes or no? Yes. And here is another capacitor. Out છે ને? And here is one more. Yes, no. Yes. You know, a very good way to understand six parallel is to actually draw the circuit. તમે draw કરો ત્યારે કઈ થાય એનાથી તમને ખબર પડે. For example, when I was drawing this, do you realize that I took the wire from here to here? See this? Light thing or nothing? Here. Because there is no branch in between. Did you understand? Turn is not a branch. I hope you understand what I am saying. Yes. Yes or no? Yes. Can you go from this to this without a branch? Yes. Can you go from this to this without a branch? Yes. Can you go from this to this without a branch? No. Yes or no? No. Okay, never mind. We'll talk about that very soon. So this battery is not connected. Right? I can pay for it. Solution જોતો તો હા શું? Okay, so what are the capacitors? બધા 10 જ છે ને? Are all 10 microfarad? Yes or no? Yes. Okay, so all of them are 10 microfarad. અત્યારે એટલે છે ને ખાલી આપણે C એવું લખી રાખીએ. Okay, લખો C is equal to 10 microfarad. Got that? But I think we might still have to talk about this. Sorry, excuse me. I 1 2 3 બુકમાં નંબર નથી આપ્યા ને? આપ્યા છે તો આપણે એમ જ ફોલો કરીએ. તમે ક્યારેક કઈ જોવો છો બરાબર છે? વાવ. Okay. All the 4 are same. Is that fine? Okay, let's start. So first step always is to identify what's in series, what's in parallel, and what is neither. What do you see? 1 2 3 and 4 are in series. 4 is not in series? No. Only 1 2 and 3 are in series? Yes. Sure? Yes. Absolutely? Yes. Correct. 4 is not in series with that. Clear? So is C1 and C4 in parallel? Yes or no? Yes. C2 and C4? Yes. C3 and C4? Yes. Wrong. All of them are wrong. ये कोई parallel मान. Let's observe this. See, like I told you, easier to identify series. You identified series correctly, but you didn't identify parallel correctly. Let's see what mistake you all made. This. Can you go from 1 to 4 without any other device in between? Can you go from this to this directly? Yes. One wire is common. Yes or no? Yes. Sure. No problem so far. Clear? But let's try to go from the other side. It should be from both sides in parallel. Series में वो कहना दियो. Series में तो एक बार सीधा ही जाए. Did you understand the differences? Yes. The parallel माहिती અહીંયા જવાનું છે. જઈ શકે? Without anything else in between. Possible નથી ને અહીંયા આવી. So is C1 and C4 in parallel? No. You cannot go from this to this from both sides without any other device in between. Directly wire નથી attached. આ wire એમ પૂરો થઈ ગયો. Got that? Yes or no? Are both wires of C1 attached to C4? No, only one wire is attached. We don't have the thing. Clear? Let's look at C2. Are both wires of C2 going to C4? Both छोड़ो एक ही रखो. Do you see that? આ તો અહીંયા જાય ને આ અહીંયા જાય. ક્યાં જાય C4 માં? કોઈ નથી જતું C4. Got it? Similarly C3. One wire from C3 can go to C4. Fine, directly. But what about other one? Understood? So is C4 in parallel with anything in this circuit? No, not right now. But we are sure that 1, 2 and 3 are in series. So try to draw a new diagram. Nobody will be lazy. If you are lazy, you are gone. 500 volt supply. C4. What do the MM say? Is that clear? What will I do with the remaining 3? I will take their equivalent. I will take their equivalent. Then you can label it anything really. Right now, let's call it C dash. Okay, C dash. It's worth noting, everyone. Have a look. This 1, 2, 3, they were in series. Do you realize they were actually connected from this point and this point? Yes or no? So just like that, here also we have connected their equivalent between this point and this point. Did you understand? Sure. ઘોડાને છે ને આમાં કન્ફ્યુઝન કે આ ક્યાં લગાડ ઇક્વિવેલન્ટ તો અમને ફાઇન્ડ કરતા આવડે છે તો ફોર્મ્યુલા પણ કનેક્ટ કે રીતે કરે સેમ થિંગ. This was connected between, I mean all the three together were connected between these two parts. Yes or no? Similarly, this is also connected between this. Got it? Sure. Okay. But what is C dash? That's what we will find out. Okay, હમણાં લખીએ છે. હજી એક ડાયગ્રામ લખો. Now, easier to identify what? C dash and C4 are in pure. હવે દેખાણું ને? એનો દેખાણું. How can we confirm? Have to. This one wire coming from here goes there. Yes. This one wire coming from here. Yes. Both the wires. Correct or not? That means they are in parallel. જે તમને કહું છું એવા વહેમમાં ન રહેતા કે આમ ઉપર નીચે છે આમ સાથે સાથે દેખાય છે parallel. It's not true. Okay. You might get fooled sometimes. એવું આમાં થયું તો ભૂલી ન જાઓ. યાદ કરાયું ને બરાબર? આમાં થયું હતું ને? આમાં તમને એવું લાગ્યું હતા? No. Okay. So now if we simplify that, what's remaining? હવે કઈ બાકી છે? આ બેને ઇક્વિવેલન્ટ કરો તો એક જ આવી જાય ને ફાઇનલ. So that's why this is called the C equivalent. Did you understand? Yes? No? Sure. So let's label these figures 1, 2 and 3. In exam must draw these figures nicely. Neither તમારાથી solution થશે નહીં. Okay? Done? Yes. First of all, we will try to find C dash. Okay, let's start. નીચે બધું લખતા જાઓ ને figure તો draw થઈ ગયા. See, you have a choice actually. You can draw figures stepwise also, or you can draw all of them together and then just do the calculation depending on whatever requirement is there. Let's start with C dash. 10, 10, 10. So C dash will be 10 by 3. Clear or not?
Yes.
Are you looking at it? If all are equal in series, then it will just be C by N. Okay, but directly no લખવું હોય તો 1 લખવાનું છે. C1, C2, C3 are in what? Series. Now લખવાનું. બરાબર? So 1 by C dash is 1 by C1 plus 1 by C2 plus 1 by C3. Therefore C dash is equal to 10 by 3 microfarad. Okay, how are you? હવે second diagram નું description. Okay, there what do we have? C dash and which is in parallel? C dash and what is in parallel? C4 are in parallel. Okay, so therefore C equivalent બસ હોય તો કઈ છે ને C equivalent. C equivalent equal to C dash plus C4. Okay, how much is C dash? 10 by 3 and C4 is what's C4? 10 by 3 plus 10 40 by 3. Very good. 40 by 3 microfarad is the equivalent capacity. આટલું તો એમને એમ થઈ ગયા. બરાબર ને? આવું આવશે ને? ગમે તેવો ડાયાગ્રામ આપ્યો હોય. Okay? The concept. આઈડેન્ટિફાઈ કરો પછી તો કઈ છે નહીં. બરાબર. Fine, so far we still have to find out something else. What's that? Find the charge on each capacitor. Each એટલે કેટલા? Q1, Q2, Q3, Q4. But some of them will be equal. Which will be equal? Raise your hand. Some of them will be equal like that. Which will be equal? Very good. Yes, Ashish. Even frequency charge Q1, Q2 and Q3 will be equal. Yes or no?
Yes.
Very good. Sit down. એટલે base find કરવાનો. Charge find કરવાનો તો ખાલી એટલું બનાવો. Okay, just find 2. Okay? Right. Fine. Let's begin with that. એમાં આ diagram નો બહુ important. ચાલો erase this. Okay? હવે ચાલુ કેવી રીતે કરે? Always from the last diagram. Always from the last diagram. I'll tell you the plan. See, if you go here, this is equal. It has 500 volt. Yes or no? But this, how was this made? દર વખતે છે ને એવું ઊંધું ઊંધું વિચારો. How was this made? આ ક્યાંથી આવ્યું? From C dash and C4 in parallel. Parallel માં શું છે? Parallel માં શું છે એમાં? Voltage. So if this has 500 volt, this one will have 500. This one will have 500. Kana voltage mali gaya na 4. So we got V4. Yes or no?
Yes.
But do you realize that if you want to find charge and you know capacitance and you know voltage, it's easy. Q equal to C. Clear? And basically, C to khabar hai jo hai generally. So it's just about these two. Ek mali jaye to bija hoyi jase or vice versa. Okay, they got in a curve. So let's start. Right? I'm not erasing diagrams because I need them. Okay. So here we can start with V4 is equal to 500 volt is equal to V dash as C4 and C dash are in parallel. Raise your hand if you understood this line. V dash. What is V dash? Voltage for that dash capacitor. Is that okay? Some already go motor બધું લખવા બેસતો તો પૂરો જ નહીં. Right? So V4 is 500 volt and that is V. So V4 મળી ગયું તો શું મળી જાય? Q4. Like I said, Q equal to C છે. C તો ખબર જ છે. So therefore Q4 is equal to how much? C4. V4. Yes or no?
Yes.
Sure. Okay, what's C4? 10 into 10 raised to minus 6. Okay, V4 500. So multiply them. So that's going to be 5 into 10 raised to minus 3. Yes or no? Yes. So 5 millicoulomb. Got it or not?
Yes.
Easy. એક મળ્યું ને તો એક જ બાકી. Clear? Sure? Right. How to proceed? You see, we have found out that the voltage for this also is 500. Voltage for this also is 500. Right? Over here, this C dash was made from these three in series. The series was same to what? After the charge find out. After another charge find out. Yes or no?
Yes.
If we find the charge of C dash, we can get the charge of Q1, Q2 and Q3. All clear or not? Okay, હવે એ તમારી પર કરો. Follow similar procedure. અહીંથી start કરવાનું ને. Q dash equal to what? C dash V dash. Okay. પછી લખી નાખો. That એ લખાવ્યું. ચલો તમે ફાઇન્ડ તો કરો ચાર્જ પહેલા. Q dash equal to C dash V dash. Pick the correct values. Okay. Thank you. 5 by 3 એવું આવે ને 5 by 3 મિલીકુલમ ઓકે વાળો કે શ્યોર fine 5 by 3 millicoulomb okay all right so what to write after that so once you have got to the point where you have q dash is equal to 5 by 3 millicoulomb then you write it as follows. C C1, C2, C3 in series make C dash. Yes or no? C dash क्या देगा? From C1, C2 and C3 in series. And that's why Q1 is equal to Q2 is equal to Q3 is equal to clear. Q1 equal to Q2 equal to Q3 equal to Q dash. So answer to I was upon answer to I was. કોનો આન્સર આવ્યો ભાઈ ઉપર ચાર્જ સ્ટોર્ડ બાય which capacitor C dash પણ આપણે તો 1 2 ને 3 નું ફાઇન્ડ કરવાનું if you sit down is this clear હવે કેનો આન્સર હવે આ જે વોલ્ટેજ ફાઇન્ડ કરવાનું કે તો સેમ પ્રોસીજર ચાર્જ મળી ગયો હવે વોલ્ટેજ મળી જાય કે દે Q equal to CV પાછું એ છે. So basically in all these kind of patches you just have to play with three things. One, in parallel voltage is same. Second, in series charge is same. And third, Q equal to CV. એમાં આનાથી આગળ કરતા જવાનું. That's how you can go deeper and deeper into it. Okay, but start end થી થાય તો easy પડે. અહીંથી તમે વિચારો જશો તો ખાલી પ્લાન બનશે, સોલ્વ નહીં થાય આ બધું. Is that clear? અહીંયા તમે જોઈ શકો these are in series. આપણની વેલ્યુ શું એના માટે અહીંયા જવું પછી they are in parallel પણ એની વેલ્યુ શું હજી આપણે જોવું. Is that okay? Yeah, but yes, with little bit of skill you will be able to do it without drawing also. On board exam also draw કરો. Got it? Okay, fine. Let's go to exercise. Question 25 કરવો છે ને તો હોમવર્ક આપી દો હોમવર્ક મજા આવે તો કરવાની ઓકે પહેલા 20 question 25 ઓકે હોમવર્ક but instead of 300 volt you connect battery નો પોઝિટિવ ક્યાં આવે ઉપર. Is that okay? See where the supply is written. Here, અહીંયા plus and minus આવું લખ્યું ને that means battery is actually connected like this. Do you understand? Yes, no. Yes. Sure. હવે બાકીની સર્કિટ ડ્રો કરજો આવું બધું છે ને draw it. Okay, first thing would be to figure out what's in series, what is in parallel. ખાલી એક હિન્ટ આપી દો જો આવું છે ને did I draw it right? Yes. Okay, number આપ્યા છે this is C1 C2 C3 okay follow hurry up C2 C3 are in series. Is that clear? Sure? No doubt? એટલે આમાં એવું જે તમને ખબર પડી જાય કે કરના પણ પછી ધીરે ધીરે ઓટોમેટિકલી સિમ્પ્લિફાઈ થઈ જાય. If you are doubtful about something don't touch it. Clear? So these two are in series. એટલે નવી સર્કિટ ડ્રો કરો પછી શું થાય આ સી દે ચલો હું તો આવી દે પેન્સિલ થી now all the three are in parallel. No, दिखावे पे मत जाओ again. Only C1 and C dash are in parallel. Is that okay? Yes. Is that clear? એટલે જો તમને કહું છું હમણાં તમારો જો અમે તો સર આમ જોઈને જ કહી દી બધું હોય જ જશે. All that will not work here. Okay, you have to follow the rules that I have taught you. Is that one wire from this side? Okay, yes. The second wire from this side? Yes. Is there anything in between? No, everything was there. That means they are in parallel. Is that clear? Yes. Fine. Yes. That's how it works. And if I simplify it, you will not. I hope you realize that. Here also to okay. But here also to what battery again, not value. There should be no device between this and this. This is not the same wire. Got it? Look at there. પછી થઈ જશે પણ પહેલેથી નહીં થાય. And if you do it directly, you will get it wrong. Okay?